Okay, good afternoon everyone. How was your lunch today? Good. Is everybody here already? Okay, let's start this class with prayer so that you can understand the lesson completely and also useful to the people around you. Okay, let's start the prayer. Okay, good. The question that we have to answer today is how do they manage to survive from these riots? Okay, this is Tony Hawk's, I guess. Okay. It's scary if we don't know the theory. Okay. Well, maybe some of us still doesn't know the theory, but since we know the expert know the theory, it becomes less scary, right? So let's find out about the theory, how they manage to survive this riots. Okay, today's lesson is related to our previous lesson about centripetal force and centripetal acceleration. You can now check your notebook to review a bit about the formula of centripetal force and centripetal acceleration. Okay, can you find it? Good. And you will use that formula today as well. Okay, so without any further ado, let's go outside. We will do an observation first, okay? Okay, guys, we will do the observation today, okay, about vertical circular motion. It's kind of noisy here, so please pay attention. Okay, I want you to fill the plastic cup with water from the tap. Okay, please fill the water, not until the brim, just half of it. Okay, that's enough, I guess. Okay, now please put the plastic cup on the cardboard. Okay, now I want you to swing it vertically. Okay, vertically is like this. Okay, not like this. Vertically, but it must be fast. Don't hesitate. Don't do it slowly. Do it fast. Are you ready?
Yeah, I'm ready.
Okay. 1, 2.
Wait. I'm afraid.
1, 2, 3. Okay. Any water spilled from the glass? No water spilling? Okay. Okay, do you want to try? Come on. You may try. Okay, do it fast, okay? Come on. Do not be afraid. 1, 2, 3. Yeah, very good. See? Is there any glue? No glue, right? You can leave the glass. Yeah, no glue. Okay, applause for both of you. What happened if I ask you to swing it slowly? Would you want to try?
No.
Just try.
The water will spill.
Will spill. Are you sure? Let's try. Fatma, please try. Swing it slowly. Slowly, hesitantly. Hesitantly, yeah, slowly. More. See what happened? Okay, everybody's here, right? Good. So, based on the observation, we know that the answer to these questions are contact force and critical speed. So today we will focus our lesson on contact force, or the symbol is N, or normal force, and also critical speed or minimum speed, the symbol is V. Yeah. As I said before, you have to understand about centripetal force and centripetal acceleration to understand today's lesson. And you also have to remember about Newton's second law of motion. Anybody? Yeah, Newton's second law of motion says that resultant force equals to mass times acceleration. Since today we will learn about circular motion, means centripetal acceleration. And centripetal acceleration is velocity squared over the radius of the circle. Okay? So, based on this equation, you can substitute the centripetal acceleration with this. So now, our equation, resultant force equals to mass times v squared over radius. Now, okay, in vertical circular motion, there are three important positions, A, B, and C. We try to find the contact force for every position. Okay, now let's see the first position. What forces are there? Okay, there is a downward force. Can you guess what it is? Yes, this is weight or mass times gravity. Okay. There's also another force here. Since you see that the motorcycle is in contact with the circle, so absolutely there is contact force here, or we call it N. Okay, so in this position you can see that the contact force N and the weight mass times gravity are in opposite direction. If we find opposite direction forces, we have to subtract, yeah, to find the resultant. Okay, so the resultant force, or sigma F, is substituted by normal force or contact force minus mass times gravity. That is the resultant force equals to mass times velocity squared over radius. Okay, that's the first position. So it's easy now to find the contact force in this position. You just have to move the minus mass times gravity to the other side of the equation. Okay. Next, it's the second position. Here we have the first force, which is mass times gravity, the weight. And also we have contact force, since you see that the motorcycle is still in contact with the circle. But the contact force is always perpendicular to the surface, so the contact force is inward. Yeah? Here is the contact force. So in this position, N equals to mass times v squared over r. Okay? Since only the normal force or contact force is parallel to the centripetal force, we don't use the mass times gravity because it's not parallel to the centripetal force. You have to remember that centripetal force is always inward the circle. Okay. So the next position, C, the top position, the most dangerous position. Okay. We see the first force downward. This is the mass times gravity. This is the weight of the rider and the motorcycle. And still in contact between the motorcycle and the circle, so we can find the next force. Of course, it's a contact force, or N. Now, let's see the direction. The directions of the two forces are inward the circle, yeah, and parallel to the centripetal force. So we use these two forces. Since both directions are the same, we have to add it. Okay. the resultant force. This is the sigma F. Okay, equals to mass times V square over R. Mass times V square over R. So if you want to find the contact force in this position, okay, you just have to move the mass times gravity to the other side. So it's mass times V square over R minus mass times gravity. That's all about the contact force. Okay, now let's try to do the first question about contact force. Let's see, a pilot has a weight of 800 Newton. He flies his plane at 60 meters per second in a vertical circle of radius 100 meters. Okay. Calculate the centripetal force on the pilot. Okay. And then B, what is the contact force of the seat on the pilot at the top and at the bottom of the loop? Okay, let's do this. We have to write the given information. The weight is 800 Newton. Okay, next he flies his plane at 60 meters per second. So that is the velocity. 60 meters per second. In a vertical circle of radius 100 meters. So the radius is 100 meters. Okay, the question A. Calculate the centripetal force on the pilot. Question A. The centripetal force. Okay, let's finish the first question. Centripetal force. If you want to find centripetal force, you need mass times V square over radius. You don't have the mass, but you do have the weight. You have to remember that weight is mass times gravity. To find the mass is weight divided by gravity. So it can be solved like this. Substitute the mass with weight divided by gravity, and this is still the velocity square over the radius. Okay, now the weight is 800 Newton over the gravity is 9.81 meter per second square. Okay, times the velocity is 60 meter per second square. Don't forget the square. And then the radius is 100 meter. Okay, let's do the calculation. Finish with the calculation is 2,935.8 Newton. Yes, that is the centripetal force. Okay, next B. The question is, what is the contact force of the seat on the pilot at the top? So normal force at the top. You know that at the top, you know that at the top the normal force has the same direction as the weight. So if you want to find the resultant force, the resultant force will be normal force added by the weight. Okay, and it is equals to the mass times V square over R. So the normal force itself is mass times V square over R minus mass times gravity. Remember that mass times V square over R is the centripetal force, so you can substitute this with the value that you already found. minus, this is the weight. You know the weight is 800 Newton. Okay. So the answer will be 2135.8 Newton. That is the contact force at the top. Okay. So we will continue now to discuss about the second condition that you must have in order to survive the vertical circular motion, which is minimum speed or critical speed. Yeah. So minimum speed for vertical circular motion. The most important position for minimum speed is at the top because it is the most dangerous. Okay, let's start with the formula that we've already learned in the previous slides. At point C, you know that the contact force is downward, the weight is always downward, so you have to add both forces because they have same direction. So this is the resultant force, contact force plus the weight equals to the centripetal force. Okay. Now what we have to find is the V, yeah, the minimum speed. Okay. So at the top, if we want to find the normal force, we have to move the weight to the other side of the equation. So the mass times gravity is now becomes negative. Yeah. So for the critical speed, regard the contact force as 0. That is just about to fall. Yeah. So mass times gravity is now equals to mass times v squared over r. Yeah, because it's 0. If it's 0, we move it back. So mass times gravity equals to mass times v squared over r, and you can eliminate the mass. So what you get now, if you move r to here and g to here, r equals to v squared over g. Yeah. Or you can also say that V equals to the square root of R times G. Yeah. So the minimum speed that you need is the square root of the radius of the circle times the gravitational acceleration. Question is, what happened? Sorry? What happened if your speed is smaller than the square root of the radius and the gravitational acceleration? Yes, it will fall because the mass times gravity or the weight will be bigger. Yeah, and the weight is bigger, of course, it will fall. So let's see the sample question. A rope is tied to a bucket of water, and the bucket is swung in the vertical circle of a radius 1.2 meter. What must be the minimum speed of the bucket at the highest point of the circle if the water is to stay in the bucket throughout the motion? Okay, it's pretty easy, right? We just have to use the previous formula. Okay, everybody has finished the worksheet, very well done everyone. So that's all for today, I guess, about vertical circular motion. Let's make a conclusion. 2 conditions for you to survive the circular motion. What are they? Yes, contact force and minimum speed or critical speed. Okay, good. How to find the minimum speed or critical speed? It's the square root of radius of the circle and gravitational acceleration. Okay, so next week we will continue to learn about circular motion and the focus will be about the back turn. Okay everyone, thank you for your attention. I'm Dora Galamir. See you next week.